So I'm here in the southeast of Sicily, first time in Sicily, on a beautiful mid-November day. And to my left, you can see the Mediterranean in the distance. We're on top of Mount Sophia, I believe, which is the home of the Catania Astrophysical Observatory and its offices. And I'm here with Isabella Pagano, who is the co-principal investigator of the European Space Agency's upcoming PLATO mission, which will launch in 2026. And she's also the director of the Astrophysical Observatory here at Catania. So tell us, Isabella, what we can hope to gain from PLATO.
Okay, PLATO will allow us to search for a planet like the Earth that orbit stars like our Sun. So we are keen to find those planets and measure in a accurate way their density. So
The density, yeah.
the density in order to say if there is an atmosphere there or not, in order to assess also with the PLATO data and specifically with astroseismology data of PLATO the age of the systems, and this will allow us to study all these planets also in with follow-up telescopes, follow-up measurements to assess their habitability, searching for biosignature and so on.
And so explain how PLATO will observe the planets. It's by the transit method.
Yes, it's by the transit method, and for the planets that will be found, we will also get the radial velocities because the sample of targets in PLATO are done by very bright stars that give us enough light to make the follow-up measurement with the telescope on the ground, and so we can measure the radial velocities and in this way also the sites. So transit to measure the sites and radial velocity to measure the mass, and at the end we derive the densities.
And we're looking at so-called bright solar type stars, F, G, and K spectral type. Our own sun is a G2 star, and you said the nearest star like our sun is Alpha Centauri A, I believe. It's almost an exact. It's not a twin, but it's a good solar analog, correct?
It's a solar analog. There are others also in the vicinity, other close twins, but of course we will not look only at the very specific twins, but all solar type stars. G stars, but also some late F or early K star can give good approximation of our solar system.
And this is a big mission. It's a €1 billion mission with 26 elements. And although the elements are not large, I mean it's very impressive. And one of the goals is to do astroseismology on these stars to better understand their internal dynamics. Is that correct?
We want to measure the physics properties of the stars, at least for a subsample of them, with high precision. And these parameters are the mass that astroseismology can deliver us and the age. And yes, this is important to understand better the stellar physics in general, but also to give us information more precise to characterize the planetary systems.
And also, you're going to be observing the TRAPPIST systems, which we've heard about again and again in the media recently. It got a lot of press. I believe there's 7 planets in the system. It's a M dwarf, which interestingly enough, you said the star is so small that's hosting these 7 planets. It's almost only a few times bigger than our own Jupiter. Is that correct?
Yeah, it's a very late dwarf. This star with 7 planets. At the moment, some of them are in what we call a habitable zone. That is a region where the temperature, given the irradiation coming from the star, is compatible to have the water in the liquid form. But at the moment, we don't have any hint that there is any form of life there. Probably there is no atmosphere around these planets. For now, we know that for 2 of them, the more close to the star, there is no atmosphere. This is a result from JWST observations. PLATO is not strongly interested to stars like TRAPPIST. Probably if TRAPPIST falls in the field of PLATO in some moment of the PLATO life, we will observe also TRAPPIST. But it is not the main interest of our mission to study TRAPPIST itself.
So the bottom line about the TRAPPIST system is probably much ado about nothing. It's an interesting curiosity, but you strongly believe there's no life in that system.
It's difficult that there is life in this system. Yeah.
So final thing, in Italy, you have a centuries-long history of astronomical observations, and you were telling me in the interview that Galileo is kind of responsible for starting the scientific method in that he recorded his observations. Can you tell me about that?
Yes, Galileo was using a telescope to look at the sky. Probably we do not know exactly, but probably he was not the only one in his age to do that. Also, telescopes were certainly not invented by him. What he was doing was revolutionary anyway, because he was reporting on his experiments. His observations were reported to the public because he published that. So this is the way science works today, and it would be without any sense to invest money just to allow me to look at a phenomenon in nature and taking it only for my knowledge. It's important that what I do is then published in order not only other colleagues but all humankind can know what are the results of the research. No? So this is the way the society can make a progress in the knowledge of nature.
And particularly in astronomy. Yeah. So thank you for carrying on the long tradition here in Italy of astronomical observations, and we look forward to what PLATO is going to do. Thank you so much for your time today, Isabella, and good luck.
Thanks a lot.